Now we discuss what is meant by slip. So the slip is a very important in induction motor. The slip of three-phase induction motor can be defined as the difference between the synchronous speed and rotor speed and expressed in terms of synchronous speed. So slip S is equal synchronous speed minus rotor speed by synchronous speed, ns minus nr by ns. So where nr is the, if you solve this one, we get nr, s is equal to ns minus nr by ns. So find out nr from this equation. We get nr is equal to ns of 1 minus s rpm and synchronous speed ns is equal to 120 f by p. Practically at no load, the value of slip may be 1% to 2% at running. Slip may be 4% to 6%. Phasor diagram of induction machine. So here the phasor diagram is a very important in induction machines. So first we draw the, in phasor diagram we draw the flux phi. Phi is a reference axis. Flux phi, we draw the flux phi and then draw the, in the same wherever the direction of the flux, we draw the IW component. So what is the IW component? IW component is a working component. Whenever the current is flows in induction machine, the no load current will be split into two parts. One is IW, another one is I mu. IW is in x axis, I mu in y axis. The sum of IW and I mu is the no load current. This is the first step. The sum of IW and I mu is a no load current. So normally all the loads are be taken as inductive loads. So the current I2 be taken as lagging. I2 be taken as lagging. So once I2 is taken as lagging, once the flux is produced, after the flux the machine produces induced EMF, that is a E1. So this is a E1. So whenever this the angle difference between flux to E1 is 90 degrees. Whenever this is E1, definitely then the opposite direction is a minus E1. So E1 and E2 produces simultaneously. There is no angle difference. So both are in same phasors, E2 and E1. So next we draw the lagging current, that is a load current, that is represented with I2. So I2 R2 is same in phase. So whenever draw I2 here, definitely I2 dash is opposite to the I2 phasors. So from the circuit diagram, the phasor sum of I0 and I2 dash is nothing but I1. So I0 and I2 dash is a I1. So whenever E1 here, the minus E1 is a, that will opposite direction. So normally the supply voltage V1 is equal to, in induction motor, minus E1 plus I1 R1 plus I1 X1 is nothing but V1. We need to find out the V1 is, so minus E1 here, draw the I1 R1. So how can you draw I1 R1? That is in parallel with I1. The resistive drop is parallel to the current. The reactive drop is 90 degrees from the resistive drop. The sum of resistive drop and reactive drop is nothing but impedance drop. So that means minus E1 plus I1 R1 plus I1 X1 is nothing but supply voltage V1. The angle difference between V1 and I0 is nothing but phi1. This is a phasor diagram for three-phase induction machine. So please see the equations. V1, already I told that V1 is equal to minus E1 plus I1 Z1. Z1 is nothing but R1 plus JX1. I0, already I told that I0 no load current, I0 split into two parts, working component current, magnetizing component current. E2 dash is equal to I2 dash of R2 plus J SX2. I1 is equal to, already I told that I0 plus I2 dash is a I1. Already we represent this in vector diagram. I0 plus I2 dash, I0 and I2 dash is a I1. So this is a equivalent circuit of induction machine. What is the equivalent circuit? Stator parameters, rotor parameters. Stator parameters are R1, X1. Stator current is I1. I1 will be split into two parts, I0 and I2 dash. I0 and I2 dash is the stator current. What is I2 dash? That is a secondary current represented in, that means secondary here, secondary means rotor current that is represented in stator. E2 dash means rotor induced EMF represented in stator. So I2 dash is a rotor current represented in stator. I0 will be split into two parts, IW and IM. So this is a equivalent circuit of induction machine, phasor diagram of induction machine.